Hello everyone. Today inshallah I will continue more problems on the continuity problems that we already started yesterday. This part is really very important. We initiated this sessions, group of sessions yesterday, and hopefully today we will finish it. I will do more problems today on the continuity issue involving the limits by the definitions or the directed limits, going through Weierstrass theorem and the rest of the continuity theories, as you will see. You have a bunch of problems in this session, so please, I would like you to go through the inequalities and relations and all the limits laws that we already did go through it in the previous session and continue solving these problems inshallah. Okay, once more I will continue the solving problems about continuity from the workbook and from the other exams. This problem here, he asks you to consider the function h x of y, and it is a function defined in more than one domain. When the case of y doesn't equal to 2 of x, when y is equal to 2 of x, and he wants you to identify the value of k for which the function is continuous. This is one of the famous questions in this part, and the solution is really very simple. All I have to do is to try to evaluate the limit of the function and to make the limit of the function equal the value of the function at the specific point or in discussing the continuity. So simply, all I will have to do, he wants me to find the value of k that h is continuous near the function at 1 and 2. So I will check just only if this point 1 and 2 is one of the points at this branch or at this branch. So once you put x equal to 1, you will find y equal to 2, which means 1 and 2 is one of the points in the case y equal to 2x. All I have to do right now is to try to evaluate the limit of the function, this branch, when y and x tends to 1 over 2. So all I have to do is to try to evaluate this limit. So once you insert 1 and 2 and substitute in 4x squared minus y squared divided by 2x minus y, you will find that I will have 4 times 1 minus 2 to the power of 2, which is 4 minus 4, which is 0, divided by 0, which is undefined quantity. So all I have to do is to start factorizing the denominator, which is going to be 2x minus y times 2x plus y, divided by 2x minus y. Then I will eliminate these two parentheses together, or these two parts together. What's going to remain is limit x, y tends to 1 and 2 for 2x plus y. That's the case. Then I will make the substitution. So replacing x by 1, replacing y by 2, I will have 4, which means that the limit of the function is equal to 4. So in general, now I have the limit of the function when x doesn't equal to y, to 2y, when y doesn't equal to 2x, but when y equal to 2x, k is going to equal to 4. And in this case, the limit of the function will equal to the definition of the function, and then the function will be continuous at this point. This is also one of the classical shape of questions that you may be subject to in your exams. He will ask you, it's a question about the continuity by the first principles, and it's really very near to what we had previously. Let's go through together. He asks you to consider the real function of f of xy, which is sine by x cubed y divided by x squared y squared. So now I want to evaluate or to have the real function which is defined by this value. He wants you to use the first principle in order to prove that for epsilon greater than 0, there exists delta greater than 0, such that the norm of x and y is less than delta and will lead to that f of xy is less than epsilon. I would start this relation from the scratch. It means that I will need to define the limit of x and y once it reaches 0 and 0 for the value of the function, which is sine by x to the power of 3y divided by x squared plus y squared, and I want to check if this is equal to 0. So I want to check this relation using the first principle. As you know, we usually seeking for having, and for every epsilon that's greater than 0, there exists delta which is greater than 0, such that the mod of x, y minus the origin, okay, it's gonna be less than delta, and this will lead to the function which is, as you can see, the norm or the mod of the function, which is sine, okay, by x cubed y divided by x squared plus y squared, and minus the 0, which is the origin, which will leave you with this definition. I wrote all of this and I solve it step by step so we can go through it easily step by step. So all I have at the time being is to start initiating the process. I would start from the function itself minus 0, which is the absolute of sine by x cubed y divided by x squared y squared less than 0. I will start by this left hand side, which is sine by x cubed y divided by x squared y squared. We already know that the absolute can be distributed between the numerator and the denominator. So simply I can get an advantage of using this relation. A over B absolute equal to the absolute of A divided by the absolute of B, and this will give me the proof that I'm dividing the numerator away from the denominator. So now I have sine of by x cubed y divided by the absolute of x squared y squared, which for sure it's a positive value, it is the square of the norm. Okay, once more for the denominator, I can use the advantage of sine of z absolute less than or equal absolute z, which means I will take an advantage of the inequality. So I will use this inequality, which states that the sign of an argument is less than or equal the argument. So simply I will have the absolute of by x cubed y divided by x squared y squared. At this time also I can take advantage from the equality relation between the absolute value of A and B. All of us know that the absolute of A dot B equal the absolute of A times the absolute of B. I will take advantage from this relation. This is, as I told you, so I can split now the denominator to be a by times x squared, which is for sure a positive value, times the absolute of x times the absolute of y. And also I can take advantage of the relations connecting these values. We know that the absolute of x is for sure less than or equal the root of x squared plus y squared. We know that the absolute of y is less than or equal the root of x squared plus y squared. And also we know that x squared is for sure less than x squared y squared. I can take advantage of all of this and they make a substitution in this relation. If we did so using these advantage or these substitutions, this inequality substitutions, as you will see, it will lead to those three relations. Now I can simplify my life. This is gonna be like that. So it is really easy to just eliminate from the denominator and the denominator those parts both together, and this will deliver the value that I have by x squared and plus y squared. Once more, I want you to remember that we started and we initiated all of this from the norm, which means it is the square root of x squared plus y squared, which is supposed to be less than or equal delta. So at the time being, I can put by delta squared less than epsilon. And here is the relation or the condition connecting delta and epsilon both together. That's delta is equal to the root of epsilon over pi. That's the condition that will deliver that limit. So you can see it's really very important just to go step by step. So once more, in order to get this relation, I can move step by step between these relations. So once more, this is according to the definition, it's delta epsilon. This guy is equal to delta squared. So the second step, I want you to remember, this is delta. So this relation will be by delta squared less than epsilon. So at that time, I can now find the relation connecting all of them together, which is delta is less than the square root of epsilon over pi, which is a confirmation on the relation that the limit exists of this function and it's equal to 0. Once more, why all these steps, why all these complications? Because it's impossible to reach a point in 2 dimensions from anywhere. So I need to prove using the differential as you saw. Okay, also he wants you to tell us what do you conclude from this situation. So if you look to this question or the formation of this question in your exam, okay, as I told you, he's taking your hand step by step. So he's giving you the rate function. He wants you to prove, he can ask you at this, try to find the limit of this function at 0, but instead of saying this, he told you just to try to prove this relation. And then he asked you, what are you going to conclude from all of this? The conclusion is really very simple, that the limit of this function is equal to 0 once it is around the origin. So either, if it was a direct question, prove that the limit of f of xy equal to 0, I will do the same steps. Or a question can be formulated in this manner. This is really very good question. I've already sent you the PDF, I believe 2 days ago through the weekend, about all of this part. Okay, this exam was in the spring of semester 24-25. And the question, it's really very simple. If you studied the part of the limit, this is really very easy to answer. He wants you to prove that the limit of once x and y tends to 1 and 1 for x squared, y squared, negative 2 divided by x minus y doesn't exist. All it takes is just to try to evaluate this limit by using 2 buses, 2 functions, and show that the limit is not equal. Okay? So all I have to do is to choose the functions. Okay, or to choose the buses. He wants you to evaluate the limit once x and y tends to 1 and 1. So it's really very tempting to use x equal to 1 as one of the passes, y equal to 1 as one of the passes. And this is what I'm going to do. So the first step in order to prove all of this, just to find that the limit it's not equal to each other through 2 buses, at least 2 buses. So I will start with x tends to 1, substituting in this limit, and then evaluating the rest of the limit, which means, Mr. Karim, I will have 1 plus y squared minus 2 divided by x minus 1. And that will give you, this substitution will give you a difference between 2 squares over 1 minus 1. Of course, if you substitute, it's going to be undefined, 0 over 0. But with a simple trick, as you can see, Ms. Judy, by factorizing y squared minus 1, it's going to be y minus 1 times y plus 1. As you can see, I can eliminate these 2 brackets together, and this way I've eliminated the 0 factor from the denominator. You have well-behaved value. All you have to do is to substitute, and so you will have, for this path, it's negative 2. I will need to use another bus. So it's really very tempting to use at this time x equal to 1. I will use the bus of y equal to 1, which is a horizontal line at y equal to positive 1. I will do exactly the same at them. Same steps, same everything. Just making a substitution, but in this case, I will replace every y by 1. So it's going to be x squared minus 1 in a similar manner, divided by x minus 1. X minus 1, I'm sorry. If you substitute by x equal to 1, 0 over 0, so it's exactly the same, making the difference between two squares factorization, then eliminating this brackets altogether, then the end is equal to 2. Since we had a different limit through various passes, then the limit doesn't exist. So all I have to do is write it down. The limit doesn't exist at the point 1. Okay, this is also very interesting, Ms. Judy. They want you to compute the limit of xy tends to 2 and 0. Okay, for the sine of x cubed y squared over 2y squared. Please, how can I say this? The skill of thinking what to do will come to you after you try to solve as much problems as possible. Because in every problem there is a hack. There is a step out. You can use it. So in this problem, okay, it's really very tempting. If I have sine, okay, z over z, when limit z tends to 0, the result is 1. So why not to form something like this? How to form it? It's really very simple. In here, I can multiply by x cubed and multiply by x cubed. Look to this value. This is exactly the argument. So I can separate this limit or this function into two parts, and I take advantage, and I will take advantage of all of this. So it's really very simple. All I have to do, multiply by x cubed in the numerator and the denominator. In this case, I didn't change the problem, as you know, Karim. But in the other way, I have x cubed over 2 by itself, separated. Then I have sine the angle over the angle. If I make the substitution of xy tends to 2 and 0, it's sine 0 over 0, which is known from our studies equal to 1, from our background. So simply, this guy is going to equal to positive 1, while this guy is equal to 0. So 0 times 1 is going to equal to 0. It's one of the consequences of the squeezing theorem, like the problems we solved it in the previous session. So once more, it's really very simple, direct. This is going to be 1, that's going to be 0. We are all set. This is going to be 1, and that's going to be, once you multiply, substitute x by 2, it's going to be 8 over 2, which is 4. 1 times 4 is equal to 4, it's already evaluated. Very simple, direct answers. All you have to do is just trying to resolve these problems on your own. Now, also this is another problem from the worksheet, and he's asking you, consider the function defined the r square except the origin. So the domain is r except the origin. For the function 5x squared y divided by, of course, it's the square root of x squared y squared. I want you to justify the continuity of f in its domain. In its domain. Of course, this function is continuous in its domain. Adham, do you know why? Remark what he wants you to do. He wants you to define if this function continuous in its domain. He didn't ask you to get the domain. But assuming that function satisfies the domain, yes, it is continuous. Then, Mr. Karim, why it is continuous? Because it's a composition of a polynomial and the radical root and the radical function. And the radical is continuous and the polynomial is continuous. So both of them are continuous. As long as you are working with their domain. Once you break the domain conditions, then there will be problems. But for justifying that the continuity of f in its domain, it's really very simple. It's just a declaration or a statement that since the composition of this function, it is of continuous functions, polynomial and root function, through its domain, it is continuous. Okay, you want you to compute limit of xy to the 0 and 0 for f of xy. You want you to compute this limit. Okay, and can f extended by continuity to 0 and 0? So he's taking your head and leading you. He wants you to evaluate the limit, and if it is possible to extend the continuity at the point of the origin. So all I have to do now is just to try to evaluate the value of 5x squared y over root x squared plus y squared. Okay, let's think just in a second. I can separate this guy. I can separate this matrix or this function to be 5x squared on its own times y over root xy plus y squared. And I want to prove this is equal to 0. This is really very simple. It's gonna equal to 0. Why? Why it's gonna equal to 0? If you remember from the squeeze, the corollary of the squeeze theory that we took not yesterday, but in the previous week, it's direct because the limit of this part by itself, it's gonna be 0. Okay, while the limit of this guy is bounded. How to prove it is bounded? It's really very simple. So all I have to do, first this part is 5x squared, which is direct. بص شايف ده؟ 5x squared. The limit of 5x squared is gonna equal to 0. So if I got the limit of 5x squared, replace x by 0, it's 5 times 0, which is 0. But for this part, which is y divided by root of x squared plus y squared, this guy is bounded. How to know it is bounded? You already know that once you have y over root x squared y squared, I can take advantage from the absolute of y and the relation to root of xy plus y squared. So simply, I can do a simple trick. Instead of dealing with this guy, I can deal with let than or equal the root of x squared plus y squared divided by the root of x squared plus y squared. Ya Karim, from where are you going to use this relation? Because you already saw it 2 weeks ago. You already saw this happening previously. So simply, I will eliminate these two guys together. Now I have that the function y over the root of x squared plus y squared, it's less than or equal 1. That's the upper bound. What's really matter for me at the time being, it is a bounded function. You understand what I'm saying? It has an upper bound. So it has a value. And since we are talking about y, I can consider it's an absolute y to be able to use this inequality relation. That means this value is less than or equal 1 and greater than or equal negative 1. Bottom line, it is bounded. Once it is a bounded value times 0, then the result will be 0 by the corollary of the squeeze theory that we took previously in the limit part. So all I have to do, as I told you, is just try to solve more problems as much as possible. So the absolute of this guy is going to be absolute of y over the root of x squared y squared. I will replace the root of y by root of x squared plus y squared according to the relations that I know previously. I will eliminate both of them together, so it's a 1, bounded, done. So once more, this guy is equal to 0, that guy is bounded, so multiplying them both together, it will leave you, of course, equal to 0. So taking the advantage, now I know that the limit exists and it's equal to 0 as I told you. Can you extend? So I'm in the situation, Karim, that this function is continuous everywhere, according to the domain. But it's not defined at the origin, am I right? But the limit exists at the origin. So in order to get a new function which is continuous at the origin, all I have to do is to just redefine this function. It's gonna equal to 5 over root x squared y divided by the root of x squared plus y squared once x and y are not equal to the origin. But if x and y, they are equal to the origin, in this case, both the function equal to 0. Okay? And in this case, I've extended the continuity of the function to the origin, as you can see. This is the definition equal the limit, so the conditions are satisfied. As I told you, this part is important in your in the next exam. You will have problems on this board. I think I've shared with you a folder. Just be sure about this because I'm really sorry for this, but during the weekend, I usually work with more than one school. Once I finish a school, I will try to, I've usually tried to send all the PDFs of the week and with exercises or workbooks or something that's gonna help you out and with more problems and more explanations. So I believe I sent you a folder containing the midterms, the previous midterms and its solutions. Please do check on that, okay?
You did not.
Yes. Huh?
It's not sent in WhatsApp?
Yes.
No, you didn't send anything. You didn't send a exams.
Okay, let me check. Once we finish, just remind me. I think I have them, and I think I sent them for you through the weekend. But let me go through it after we finish, okay? Okay. So you will have much more problems than this, so you can speculate the shape of your exam. Here he wants you to consider the function defined by g of x, y, sine, exactly like the previous one, sine x squared over the root of x4 but to the power of 4 plus y to the power of 4. Once xy doesn't equal to the origin, but if xy is equal to the origin, it's 0. So he wants you to compute the limit of g at the origin along the lines y x equal to 0 and y equal to x. In this step, he wants you also, and this is, as I told you, a problem from a midterm. He doesn't want everyone to use a different bus. So he wants you all to use how many buses? Just only 2. The x equal to 0, which is the y-axis, and the line y equal to x. All I have to do is to, as you know, for the first part, is to make the substitutions through the y-axis. So I will substitute in this function by x equal to 0. And once you do so, it's going to be 0 over y squared, which is 0, because the value of the substitution is before the use of the limit. So the limit at x equal to 0 or at the y-axis is going to be equal to 0. So if I used y equal to x, all I have to do is to replace, in this situation, all the value of y by x. So it's going to be the root of x power 4 plus x power 4. That's going to be. So it's going to come up to sine x squared over root 2 times x squared. And in this case, it's going to equal to root 2, 1 over root 2 or whatever, 1 over root 2. This is the value of the limit. If you remark, Karim, the value of the limit of the function g around the origin is not equal to each other. So the limit doesn't exist. Do you read me? The limit of this function at the origin doesn't exist. It is defined, but the limit doesn't exist. Are you with me? Okay. And as I told you, as long as these two limits doesn't equal to each other. He wants you, does the limit of g at the origin exist? Answer, no, doesn't exist. In A, we have found 2 different passes to the origin, and they have different limits. So it doesn't exist. So now he gave you the way, شايف يا Adam, to use the directed methods. Then he gave you a degree, a grade in here, a mark in here. Then he asked you what's that relation or what's that result stand for, another mark. And he asked you, is G continuous at the origin? Justify. So, G is continuous at the origin. Why it is continuous at the origin? The limit of the function, as you can see, exists and it's equal to G of 0, 0, and G has no limit at the origin, so we conclude that G is not continuous at the origin. We know the condition for the function to be continuous, that the limit should equal to the definition. Now I know that the limit doesn't exist from parts A and B. While the function is defined, it has a value. The value is equal to 0. Okay? So they are not equal to each other. This part is not equal to g of x, y equal to 0 because simply it doesn't have a limit. Okay, once more, he gave you a problem. Also a problem came previously in one of the exams. He's giving you, consider the real function f defined in R, which is y equal to x plus sine pi of y. And consider also the set. So he's giving you the function, and in this case, he will ask you about the theories of the continuity, the theories of the continuity. As either Weierstrass theory or the range theory that you will see. Okay, so this is the set which is defined by x is less than or equal -2, greater than or equal -2, less than or equal +2. So this is the x-axis, that's -2, that's +2, and that's your axis. And for y greater than 0, this is the x-axis, up to y is equal to half, so it is the rectangle from -2 to +2, and it has the lower bound, which is 0, the upper bound is half, as you can see. You want to justify that f has a maximum and the minimum in S and determine their values. There is conditions for this to happen. What's the conditions for this to happen, if you remember? We really did go through this Weierstrass theory yesterday. It has to be, your function has to be a compact set. Yes, Mr. Karim. A compact set, it's related to the topological part of our course, the first week and second week. Compact mean the set is bounded, okay, this is number one, and closed. That means compactness. So I will start from this point. Okay, f is continuous function in its domain, that's the first condition for applying Weierstrass theory. Number two, it is a compact set. This set is compact. Why? Number one, it has boundaries, so it is a closed set. Number two, I can draw a ball with a certain R and having all of this inside it. So the first thing is it is bounded because the boundaries are x equal to -2 or x equal to 2, and with y greater than or 0 or less than 2. Or just to replace them, get the range on the x direction and the boundaries on the y direction. So this is the condition for the boundary. So it is closed set. Why it is closed set? Because simply, خلي بالك, I can get a ball centered at the origin. I can make an open ball centered at the origin with radius equal to 3, with radius equal to 4, with radius equal to 5, or whatever, and it will be completely contained. So it has a boundary, and also it is closed, so it's a compact set. So as I told you, bounded set because there is an open ball that can be drawn. I wrote this for you. Okay, now f is continuous and it is closed and bounded, which is a compact set. By Weierstrass, this function at this set, it has a maximum and a minimum. And that's a direct application of Weierstrass theory. So inside the region that we are talking about, we will have a minimum and a maximum. Okay, if you look to x from -2 and 2, and y running from 0 to half, and I want to get the range of this function, I can get the range in order to know the maximum and the minimum boundaries. How to get to this point? Okay, I will start that y is greater than or equal 0, greater than or equal to 0, less than or equal to half. I need to find the by times y. So I will multiply all those guys in by. So it's gonna be 0, less than or equal by y, less than or equal pi over 2. That's the case. Then I will take sign for all of them, for all the three parties. Sine 0 is gonna equal to 0. This is gonna be sine by y, and that's gonna be sine 90. Sine 90 is +1. Now I have this part of my function already between greater than or equal to 0 and less than or equal to 1. Okay, if I used the boundaries, putting x in the relation that you can see, now I can speculate the values. So if I used x with the relations from the middle, from 0 up to 2, if you insert C0 at this relation, you will get the lower bound, and if you insert x equal to 2, you will get the upper bound. This is why x plus, -2x equal between -2 and the +2. So The lower part will be with negative 2, the upper part will be with positive 2. So the range, the minimum value of the range will be negative 2, and the maximum value of the range will be to positive 3. So already, what Weierstrass theory tells us that the value of this function, through this region, it will have two peaks. One of them is going to equal to 3 according to the range, and the other one, the minimum, will be equal to negative 2. And it will be running between both of them. Now I can, okay, the minimum will happen at negative 2 and the maximum will happen at positive 3. Determine, justify the range of the function, we already did, and we already have the comment. In C, the range, of course, it's running from negative 2 up to positive 3, and according to Bolzano's theorem, there is value between the minimum and the maximum belongs to this set, where C is between the input of this function, and that's Bolzano's theory, as you can see. Another problem exactly the same for f between two variables, continuous set, where y is greater than or equal to 0 and then than or equal to e of x. By the idea, this is really very simple to show, because as you can see for this set, this is the main function, which is y equal to e to the power of x. That's y equal to e to the power of x. This is the point at 1. But I need to find the values of y, which is greater than 0 above this line, but less than the curve. So I'm talking about this part, that's the set that we are talking about. So once more, this is the set. Knowing that a function, you don't have the function, but you have the values of the function at certain points. The point 1 and 1, so at x is equal to 1 and y is equal to 1, I have the value of the function, which is 1. And the value of the function at x equal to 2 and y equal to 1, the value of the function is equal to 3. He is asking you, is it possible to guarantee the existence of a point in between these two guys, such that f of ad equal to 2? Yes, I can. Yes, I'm sure that in between these two values, okay, which is between 1 and 1, it's equal to 1, and at 2 and 1, the value of the function is equal to 3, that's the 2, okay, that's the function, the value of the function at